Okay, well, thank you very much, Gaëtan. And it's a real pleasure to be here. I'm just astounded by the sort of presentations that I'm seeing here. It's purely a delight to see so much interdisciplinary work with artificial intelligence. So I believe I am the sole representative of the social sciences here today. I'm a political scientist, but I'm going to take on the hat of my larger discipline, which is the larger family, which is the social sciences. And in particular, what I'm going to do today is I'm going to discuss with you kind of a survey of how social scientists use artificial intelligence tools in order to study images at large scale and to try to answer questions that are pertinent to the social world, be it the political, the economic, or the social world. So the title should actually add in there as social scientists, but I kept it a little bit more general. Okay, well, why do we care about images? Images, of course, if we start from the starting point of how, we are visual animals, we're visual creatures. We learn visually, we perceive the world predominantly through vision, of course not exclusively, but predominantly. And so images for social scientists convey narratives that are very important. In the top row here, you see kind of these iconic images from either the Tank Man or Obama's poster during his first campaign, images from the Great Depression that are iconic, and kind of environmental images here, the polar bear, and then Earthrise, which is the first image basically from looking down on Earth, basically. And so these are powerful images that convey their own narratives and their own stories. But then also we have sorts of images that are important for us that convey more tangible information. So look at the series of political protests, starting from the women's suffrage movement and going on to the gay rights movement in the 70s and the 80s, all the way up to kind of the revamp of the civil rights movement in the United States more recently. Now, these sorts of images have within them information that can be important for social scientists who are trying to test theories, and they're seeking empirical data that is not necessarily found anywhere else aside from images. So what are the sort of nonverbal characteristics of people that are in this image, or how many people are there at the protest, or what are the sorts of facial expressions that they have, on and on. So these are just some aspects of imagery that's important for social scientists, but you can even take it a step further, and you might have satellite imagery that over civil areas that have gone through civil wars, and you can infer sorts of amounts of damage to villages, etc. There's all sorts of applications, and I'm only going to go through a few, but what I want to do is I want to talk a little bit about what we mean by computer vision, and from there I'm going to talk a little bit about sort of computer science techniques that are applicable in studying the social world, and then I'm going to talk about a few papers, one of them being mine. So there's a little bit self-promotion here. Apologies. But there's another paper that's not mine. And thank you. And then we're going to, I think it's important for us to talk a little bit about ethics, just a little bit, but I think it's important to do so. Okay, so by computer vision, what we mean is, there are many definitions here, but one kind of all-encompassing one is that this is an interdisciplinary field that uses artificial intelligence tools, and that enables computers to interpret and make decisions based on visual data. And it somehow needs to emulate how we as humans perceive and understand images. And even taking it a step further, what the objective is to automate the capabilities of the human visual system, right? And to be able to take informational insights, or rather informative insights, as I say here, from visual input, and then do as you will from there, right? And as social scientists, we're not typically interested in manipulating our environments based on that. Engineers might be interested in that, say, an application of computer vision to robotics. But we as social scientists are much more interested in extracting data from images in order to test hypotheses. So very quickly, kind of what do we mean by the sort of the components of a standard computer vision application would be something like, I need to gather images. So I need to capture visual imagery. This can be done various ways, through cameras or on your own, or if there are images out on the internet, you can write up programs that can automatically download these images, save them to your hard drives at very large scales, and on and on. And then there needs to be some set of kind of processing or pre-processing of images. This will make a little bit more sense along with feature extraction, as I give you an example of one sort of architecture that's quite common in studying images. But basically, we need to set up the images in such a way that they can be processed. And we want to identify the most relevant information from this process image that we can focus on when we are, say, learning the patterns, which is the last and, of course, the most important output here is understanding patterns that are in large sets of images, so that we can then create a model to be able to predict certain outcomes that we're interested in. And this will make a little bit more sense, I think, as I move forward. So there are a whole host of computer vision techniques, but we can think of them in the larger family of the machine learning world, right? So you might have supervised approaches where I have a set of images that have been labeled by humans, and I create I teach a model, I train a model in order to be able to accurately predict those, what we call classes, from a set of images. There are also unsupervised approaches, right? So I don't actually have a human labeled data set, a set of images that I've labeled into categories, but I might want to learn sort of how a bunch of documents might be able to cluster with into a much smaller set of categories without any human supervision. And those sorts of methods exist too. And now we're also kind of in this world of kind of generative AI, where we can generate images, and we can go from text to images and images to text. And this is also kind of, you can fit it into the sort of supervised approach, but it's kind of stands on its own. So I'm going to be talking mostly about the supervised approach, but I'm happy to answer questions about others as well. So just very, very briefly, the sort of common architecture that's used to classify images is what we call the convolutional neural network. It's performed very well for us. And the way that this works is basically you have an input of an image into the system. Well, what is an image? It's just an array of pixels, and pixels are carry numerical values. If it's a color image, it has 3 numbers, red, green, and blue. And so this input then basically becomes, it's 3 layers of numbers. But let's just imagine that this is black and white. Well, that just means that each pixel in an image is a number between 0 and 1 that goes from white to black. Yeah, and then everything in between. Well, then eventually what happens here, well, that's a numerical representation of this image. There's a series of, in the convolutional neural network architecture, there's a series of pre-processing steps that take place in order to compress an image that might be thousands by thousand pixels into a much, much, much smaller set of numbers in one line, in one list, right? One layer, but that nevertheless represent, those numbers actually contain the actual information of this image, but at just a very much smaller dimensionality. And then this is what we call the input layer into a neural network. And throughout the day, we've been hearing this term neural network. It hasn't really been defined. So maybe me as a social scientist, because I'm not a computer scientist, I can try to maybe just very, very quickly just tell you what's might be a decent explanation of this right here. So, you know, what happens here is we have this list of numbers, right? That is a representation of this image, but it's just a list of numbers. But what we want is we want to convert that list of numbers into a prediction of a category, yeah, that's of interest to us. And so what happens is that we pass this information in this input layer through a neural network, right? That has what we call hidden layers in here. That each of these nodes is basically, you can think of it as a faucet, and water is coming through this faucet, and the faucet can either not allow the water to move forward onto the next faucet, or it can allow a little bit of water, or it can allow all the water to go through. That sort of allowance of water passage, if I use this analogy, is learned in over many iterations, starting from random to basically a sort of setting of these values such that we can get proper predictions at the end, right? So zebra goes in, zebra is predicted out. That's more or less what's going on here. And so what can we do with this sort of approach? Well, we can try to do things like object detection. And so there are models that have been trained on, the output layer has thousands of outputs, thousands of sort of categories, and the amount of data that's been trained on is just a massive amount. And so the computer is able to detect objects with some sort of probability here, right? And so here's an image of American soldiers, and we have these bounding boxes that are predictions of objects within this image. And as we can see, it makes sense, right? We have a rifle with 70% probability, a helmet with 82% probability, on and on. And we can see here from an image from the Hong Kong protests that, you know, is the umbrella revolution. And the umbrella here actually carries significant interest for us as social scientists, and on, right? We can see Obama having a beer, right? So you might be interested in, say, how do members of the American Congress communicate gun ownership on social media, but not through text, but through images, right? And you might collect all of the images that have been posted by every member of Congress in America, and you might start counting guns, right? And see, then you might test downstream, are right-wing or left-wing candidates, or elected officials rather, more or less likely to display images, and when do they display images of weapons, right? And what about around the times of mass shootings? Like what is the sort of politics of that, right? So this is all information that is not available in text necessarily, but many times people convey these things with images. So here I want to go over a little bit some examples. I'm going to have two examples of research that social science research that uses let's call them images as data approaches, as we call them in the social sciences. The first is by Zhang and Pan, 2019. This is a very interesting study that they are very much interested in how are social protests communicated on Chinese social media. And of course, this is of interest because there's censorship in China. China's an authoritarian state. And so communication on, say, a platform like Weibo is censored, right? It's monitored. So a lot of times text is very difficult to communicate sort of collective action events. However, just showing a collective action event, right, is a whole nother thing, right? And it's not to say that there isn't censorship of images, but and so what the researchers are doing here is they went out and they collected a very large collection of posts on Weibo, which is a very popular Chinese social media platform, and they're able to train a convolutional neural network that is able to predict the probability of this being a protest or not. And from here, they're able to make predictions, right? And so these are examples of images of protests that were correctly classified as such. Well, the next question is, what do you want to do with this, right? Well, now you have counts of protests in a black box society, basically, and you're able to then create a database where you're able to see the geographic or the temporal distribution of protest events in China. And then you can start testing hypotheses about what leads to protests, or what are the effects of protests, or what sort of adaptive or strategic behavior does the government of China carry out in the face of protests, and on, right? But this is all information that's been extracted from information that's encoded within images. Moving on to my own research, we are interested in, my co-authors and I were interested in the nonverbal political communication of candidates during democratic elections. And more particularly, in this particular paper, we're looking at kind of what is the relationship between a candidate's gender, their emotional expressions, their nonverbal emotional expressions from their face, and how voters react to that in real time. Okay. And so what we did is we collected the video of 4 debates in Germany for the chancellorship during Angela Merkel's period. So we have full videos from 2005, 2009, 13, and 17. And what we want to do at the same time, the German election study had funded focus groups at the time of these debates. So these are televised debates. And the focus group has, each member of the focus group has a dial. And in real time, they are turning this dial to the right if they agree with what they're hearing, and to the left if they disagree with what they're hearing. So we have real-time information of voter reactions to what they're seeing, basically. And so what we want to do is we want to help explain the variation of those dials, right? Going right or left, seeing whether the facial displays of emotion of the candidate, Angela Merkel, versus always her male opponent, whether she is treated differently if she shows an angry display or a happiness display. And that sort of emotional, and we have theories as to expectations as to what we would expect here. So let me just walk you through this because I'm running a little bit behind on time. But basically, we download these images and then we break them into their frames. Yeah, so we have a little over 500,000 frames, image stills, and then we detect their faces and we infer their facial expressions. And we're only really interested in anger and happiness. And we also have some other stuff, the emotional intensity of their voice. And also we take the transcripts and we're able to do sentiment analysis with natural language processing here. So we have a multimodal sort of data set here of the candidate's performance during the debate. And obviously also we have the reactions from the voters in real time. And so then we are able to kind of study, at the voter level and at the candidate level. I'll be presenting work here from the voter side. So basically we see that in most of the debates, Angela Merkel, whenever she shows an angry face, she's punished, right? Controlling for all these other things like her voice, what she's talking about, the subject, everything. Most of the time she's punished, whereas when she shows a happy display, she's rewarded. And for the male opponent, it's the inverse. So when the male opponent is showing happiness, typically they're not rewarded for that. But when they show anger, they're rewarded. And you might say this might be an Angela Merkel thing, and maybe, but in the last election here in our data set, we also have a minor party debate. So there were smaller parties, 5 of them. I believe it was 5. 2 of those candidates are women, one from the far right and one from the far left. And they also, relative to their male opponents, were punished for anger displays. We don't see a real positive effect for happiness, although the coefficient's in that direction. So I just have 1 minute to talk about ethics, which is bad. Just a brief, if I may, just a couple points here. there are two things really when we're thinking about images and studying images at large scales and using these big models and how they've been trained on massive data sets. There's kind of two things to be concerned about. One is data privacy, of course, right? So we don't really know a lot of times where these images are coming from, what's going on. And this is something that others that have presented about generative AI, this is a real problem that they face, right? But I'm going to focus a little bit more on this bias and predictions. And what we find is that because a lot of these models have been trained using human labeled images, the sort of predictions that we get might convey the sort of inherent biases that might exist among the coders, right? And so, and this was studied in 2019 by a group of social scientists, where they took the official portraits of members of Congress in the United States, the official portraits, right? And you have men and women, of course. And what they did is they passed those images, those portraits, to one of Google's models at the time that was able to predict labels, describe the image. And what they found was that women politicians are more likely to be described according to their physical characteristics, right? So the most frequent predictions were things like girl or smile, fun, fashion, woman, blonde hair. Whereas men are more about kind of their profession, right? So official suit, business person, that's wrong, of course. These are members of Congress, but military officer, energy, on and on, right? So this is revealing an inherent bias here, of course, amongst labelers, that pictures of women get labels of physical appearance, whereas occupation is primarily the labels that go to men. And this is just one instance of inherent biases amongst labels that we need to be concerned about. Just one other thing, of course, is that we have more on the data privacy side and more a little bit more generally, not necessarily with the labels, is that we have this dual use dilemma too. We always have to remember that we're creating these systems to try to do good, right? To try to understand the world better, to try to manipulate our environments in order for human progress. But of course, people can use these systems for nefarious purposes as well, right? And so we always need to be cognizant of that. So I just wanted to convey in my last screen here, and I'm sorry I'm over time, as typical with me, that we need to understand that we are in a completely different world now. We're entering, especially with visual language models, which were discussed in the first presentation today, about these models that are able to decode from images to text and from text to images, that we are now able to extract, the sort of applications here are kind of, we don't understand really what we're able to do now, basically, is where we're at right now. And so we can gather massive amounts of social media content. We can study it at very small level, or at a granularity level that's unprecedented. And we can understand and decode human behavior across societies and norms now at a much easier way. And this multimodal aspect that I talked about is very, very important. But we always need to be cognizant of ethics as we move forward. So that's all I have for you, and thank you very much.
Thank you very much for your brilliant presentation. I wanted to ask you something, because I was struck by the fact that you choose for nonverbal extraction, the feature of nonverbal extraction, you used fixed images, if I understand well, no? You said you extract frames, but a smile is a movement that develops over time. And you know that there is this ambiguity of the fake smile or the real smile that is done by basically contracting the eye before the muscle through this muscle that connects the two. So it was identified like the real smile starts with the eyes, and the fake smile is my mouth saying, hello, how are you doing? And without the intervention of the eyes. So I wanted to ask you why you didn't choose a sequence of images instead of one.
So this is a very, very good question. And of course, looking back on it now, it's quite simple what we did, although it's incredible at the same time. And I'm not saying incredible that I did something. It's incredible the technology that we're able to use. But this is a very, very good point. And the particular model that we used was developed by Microsoft. But in hindsight, we should have relied on open source. We should have done some stuff on our own, actually. And this is just a general point, is that in the social sciences now, and I'm sorry, I'm going to get to your question, but in the social sciences, we're now very much, people are becoming more and more vocal about the need to use open source, either if it's generative AI or whatever it is, because, for instance, in this case, no one is able to replicate this paper because Microsoft has actually discontinued this service. So no one can actually replicate my study, which is a very, very big problem in science, because we always want to be able to replicate as we move forward. But getting to your point now, in fact, what we have here are averages at the second level, right? So in 1 second, there are, I forget here how many frames per second in these particular videos, and we're taking averages. But this is not exactly, it's not exactly measuring what you're talking about, which is what we should be able to measure, which is a true versus a fake smile. Yeah. And so the only thing that we can really do is observe the manifestation of the emotion, or the display of the emotion, actually. And we don't know, actually, we'll never know, or I can't say never, because in science we shouldn't say never. But it's very, very difficult to infer what's going on inside the mind of the subject. Yes. All we can see is the display. However, there are much more sophisticated ways that we can do this, which is kind of going back more to theory, like Paul Ekman was measuring kind of all these different points of the face and all the different combinations. And, he would claim that he could determine whether there is a true smile or a fake smile, or a true laugh versus a fake laugh. All that has been studied, but that level of granularity with this model we didn't have. But I think in the future we will have these sorts of things. And so it's something to look forward to, I think. But this is a very, very good point. Absolutely. We were banking on the multimodality here, that we have the visual, we have the vocal, from the tone measuring the fundamental frequency, right, as a proxy for emotional expression, and also the actual verb, the words that they're using when they're speaking. The combination of all those three we thought would at least convey anger or happiness, which is what we were interested in.